in this comparator, we looked at it or comparable we whenever you want to use the comparable, basically the first thing that should come into your mind is compare to method, which is there in comparable java.lang.comparable class, will be used by TreeSet to sort the elements in the collection, TreeSet collection, right? And not only that, whenever you want this comparable to be used, this compare to method need to be used for comparing purpose, for sorting purpose, then you can go for comparable class based on a single element, based on one of the elements sorting. And comparator is like an independent class. Comparator is an independent class Okay, comparator is an independent class where you can write your own logic for comparison purpose, but you can reuse it wherever you want. Let's say you want to sort your array list itself. How can you do that, right? Using comparable you cannot, because compare to method is not used by ArrayList. Compare to method is used by only TreeSet, right? So in those cases, like, you can go for comparator. Not only that, you have an independent logic apart from your object, right? So that is another advantage, and remaining things are same. So let's write a program and we'll start. You can start understanding the concept easily. Let's take another piece of first. Let's take a simple class, the movies. Okay, and then I'll just so what and all when you say movies, right? Sorry, you should use movie. Collection of movies. Movie is movies, right? Refactor, rename. So basically what will be there in the movies? First thing is private string name of the movie, right? And private string country, right? Not country, language. Okay, we'll use simple words. And then private int rating, something like 5 out of 5 or something. Okay, and private double cost. Can we take something else? Into a string. Yeah, you good. So now there are two ways to set the data if you want to. One is using constructors, another one is setters and getters. Generally, setters and getters is always good, but for the sake of easy doing, I'm going on generate setters and getters, and I'm going with constructor. So what I will do, I'll define a constructor here, movie, which will take string name, string lang, int rating, and double cast. Okay, and all you need to do is this dot name equal to name, this dot lang equal to this dot rating equal to this dot cast. Try to come little bit early, Teja. I think yesterday also you came, but I didn't. Try to come little bit early. Nobody is going to arrest you if you come early. Then what and all things we need to add here. One is the basic things, right? Hash code and equals for sure. By this time everybody agrees, right? And toString is good too, not mandatory. Comparator only if you want, but as in this example we are not using comparable if you want. And if you want to implement compare to method here, you need to implement comparable interface, right? We don't want to. We are trying with comparator, which is there in java.detail. Okay, this is our simple movie. Okay, next I will take a class comparator scenario, comparator demo, whatever. Okay. Here basically what I will do is, can we take directly, yeah, we'll try. What is there? Movie m1 equal to new movie, name is what are the new names coming? Game of Thrones. I'll just call it as name. Okay, movie English, sorry, it's number, right? 10, cost is 30.5, something like that. Okay. I will repeat this. Writing code is not easy, difficult. Finding out the examples is difficult, right? Breaking Bad. Marcos. Last man standing. 8, 9, leave it 10, 40, 20, 60, and then yeah, we'll take another movie. See, I haven't found one single movie. Huh? It's funny, right? I just use, okay, not exactly, just to make differentiate. My goal is just to, okay, that is what we're doing. M2. We have 5 movies with us, okay. Now we want to sort them sometimes based on movie, based on rating. Let's give different ratings also, right? So that, okay, we're back. This time I'm not going to leave, no matter what. Now what I will do, simple thing, right? Whatever we know, I'll try to take into a list of movies, I'll call it as movie list, M list equal to new array list. Okay, so all we need to do is m dot list dot add of m1, repeat same, right? No confusion here. Okay, now we add into the list. So our goal is not just add and display, right? Our goal is to sort them out. So first thing is, let's write SYSOUT just to display them, okay, whatever the order before sorting. Okay. So how do we do that? For movie equal to movie list, what is it, M list, right? We have for each movie in M list, all you need to do is display SYSOUT M list, sorry, M. Let's run this program, hopefully it should run. Yeah, so we got before sorting, same way, whatever the order you insert, it came into the same way, right? We good, we are good here. We have no confusions, right? Now our goal is to what? Sort it using comparable. So what you need to do is, so what kind of comparison you need to decide first. You want to decide sort by rating, and you want to sort by name of the movie, right? So if you sort by name of the movie, the first one comes is Breaking Bad, and then uh, Friends, and then Game of Thrones, and then Last Man Standing, and then Narcos. So that's how it displays, right? So what we need to do is we need to write a separate class. I'll say name based criteria implements comparator, implements comparator, right? We need comparator. Comparator, you need to let what is the comparisons you are using, what is the object that you are using for comparison movie, right? When you do that, ask for hidden implemented methods. So comparator is having a method called compare. Comparable is having a method called compare to. Compare to takes only one object and compares with this object, the corresponding object class. Here you need to pass explicitly two objects to compare, because you are doing outside of your class, outside of your movie class. You are trying to compare and make a decision, so you need to pass it outside, right? So all you need to do is, now you need to implement the logic here. Name based criteria, right? What is the name based criteria that you do? Return m1 dot get name dot, not m1, right? It came o1. Okay, o1 dot get name dot compare to o2. o2 dot, you need to pass get name, right? That's it. Now you have a name based criteria. Let's say you want you haven't created a link between this name based criteria and your list. Okay, right? There is no criteria has been established. You just created separate class with this name based criteria. I'm going to write another class called rating based criteria. All I need to do is implements comparator, and it takes what? Movie. Now you need to implement an implemented method. Control 1, okay, for that whatever I did. Here all you need to do is rating. What is the rating that we have here? We are using what you call the double, right? We are using for rating is int or double? Int. So the way we need to return is return o1 dot get rating minus o2 dot get rating. So this will be either either positive number, equal number, or negative number. Agreed? Okay, so nice. Name based criteria, then so you have two criteria with your hand. Now you have array list. How do you pass that array list? The criteria that you defined is using the collections. You remember? I want to open that class. Load it. Yeah, there is a class called, in the classes, these are the interfaces. Collection is an interface, collections is a class, collections is a class. Okay, so we are using that collections class dot, there is a lot of static methods are there. Okay, sort. Okay, here what I'm doing is I'll pass the movie list and the criteria. For me the criteria is name based criteria. Okay, I'll create that object, name based criteria object. Okay, I'm passing name based criteria object along with array list to this collection. This will do whatever the supposed to be do, whatever the logic it's supposed to do, it will do it using that criteria. Okay, so it will sort these elements in the array list. It will go use this array criteria that you written and sort it. Okay, so and update into the same list. Okay, so it will get automatic auto update. Okay, so let's see sys out after sorting. Same thing we need to use, right? Let's display. So before starting Game of Thrones, Breaking Bad, Narcos, Last Man Standing, Friends, right? After Breaking Bad first, Friends next, GOT next, Last Man Standing, sorting. What if you want to sort by? So now you have luxury, right? Whoever want, there wherever want they can add it. Now you want rating based criteria. That's it. Let's run. Now the rating based criteria should be 10, 8, 10, 9, 8, 7, 6 sorting should be there, right? See? 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. So sequence order it came. So if let me try to show you the one more thing. Now it displayed as 6, 7, 8, 9, 10. It's in the ascending order, right? I'll see. I think I can produce this. Now let's run this program. See, the sequence has been modified from 10, 9, 8, 7, 6. It become descending order. All I did is I changed the way I compare. I moved, earlier I was comparing with O1 with O2. Now I am comparing with O2 with O1, reversed it. Okay. Okay. If you compare O1 first element with the second element in the so natural order. Natural order is with nothing but ascending order. Otherwise, if you do it in a reverse way, O2 comparing with V1, it will become descending order. Same thing for name-based criteria as well. So now, did you guys understand now how comparator was? So the good part is, even whoever want to create this object class, now the comparison is not tied up with your movie class. First thing, it's a good part. Second part is, you have an independent logics. You can write as many comparator criteria as you want. Different, you can write another one like name and writing based criteria. Name is your first priority, and then if the both names are same, then rating, or else rating and name based criteria. So where you will first start it out based on ratings. If both movies got 10-10, then you look for the names. Okay, and all you need to do is pass it here, right? So now you are able to sort a list, an array list which doesn't have a capability to get sorted. With the help of collections and the criteria that comparator method that you write, you are able to sort it. Clear? That's it all about comparator and comparator. So next move on to what you called HashMap. HashMap, as we understand pretty much about collections in the first section, if you look at HashMap, is map is separately having hash tab as table, linked hash map, sorted map, and it has TreeMap. These are the four things we have, right, from the map family. And so which means here whatever the functionalities that has been there in the collection or list or set, you don't get in map. Okay, collections is having size, empty, contains, iterator, to, array, add, remove, contains all, add all, remove all, retain all. These are all the methods that are been available in collections, interface collection interface. But map as an independent family, but it's a collection framework family, but it's an independent of collection, so you don't get those functionality. But map has its own functionalities. Map interface has its own specifications. Did we wrote anywhere? I wish I have somewhere. Yeah, interface map. It has its own size, empty, contains key, contains value. Earlier you have add and get, right? Here you put and get, not add. You don't have add in map interface. Put and get, remove, put all, clear, key set, value, some entry set. Entry set will give you a set, values gives you collection, key set gives you set. Okay, keep that in mind. And then we move to HashMap. HashMap, how maps are, how the map family is different from collection, right? All the collections as of now we learned is a bucket, a single bucket which will hold some values, right? A bucket which will hold your objects. But map is a key value pair, a key value pair holder collection, which means, okay, so key value, corresponding value. Let's say you may have a ID here, student object, of that student object, student name, student roll number, student course, all the stuff, but you can just keep it as ID here, and here 9 some ID and student object again. So it's a collection of key value pair. Okay, so how does it implemented internally? So basically internally simple, remember, if you guys remember earlier I said, right, as it's a key value pair, key buckets has been implemented using HashSet concept. Key buckets are used implementing as HashSet concept, and the value bucket used using ArrayList. So with together HashSet and ArrayList, HashMap has been formed. HashMap has been formed. Okay, so like I said earlier, right, how the HashSet will be stored the values. Max length is 16. You remember, max length is 16. It starts with, like, 0 to 16, and we use a formula called what is that formula? Hash code ampersand n minus 1. This is the logic which will determine within this 16 bucket. Okay, let me show you. Let me prove you buckets, right? I'll write hash code hash concept. or else we can use existing comparator demo. It has already hash, right? So M1 hash code, right? So we'll get first, forget about it. Here we'll do, I'll take M1 object dot hash code and okay, and what is that, 15. Give me a second, I'll try. Let's see what value it will display. M1 bucket. See, the bucket name, bucket size is 9. So I mean the bucket value is 9. So whatever the object that you use, so let me try, I will try to show you all the buckets. It will fall within 16. This is the formula it uses to calculate where it's supposed to go. See, 9, 5, 6, 12, 12. It is M5, right? Yeah, 9, 5, 6, 12, 3. Each one is going into different bucket. There are certain scenarios where your hash code will be returned same hash code for more than one movie, because what is the object? Yep. See what I'm trying to say, right? Like let's say without this 15, that is the formula that uses hash. Yeah, I'll tell you. So here this is the hash code value, right? This is the hash code value of M1 movie. M1 movie is nothing but your M1 movie is a Game of Thrones French 10 and 30.5. So if you go to here, your hash code, look at here. Hash code is using this formula to find out this hash value. Below highlighted this hash value, right? This is the hash value for Game of Thrones French rating 10 30.5 using this logic. Once it identified, it need to go into the bucket. So remember, your hash map size is 16 no matter what. Your hash map size is 16. It doesn't grow at all. Okay, and the formula it uses to identify where your object should go is hash code and n-1. It is not logical and, it is just an ampersand. And what it does, it uses for what you called damn it, I forgot, man. Let me show it. Logical and, it's not logical and, bitwise operator. Sorry, I struggle to find out this word. Bitwise operator. Bitwise operator, 1 and 1 equal to 0, or 1 and 0 is equal to 1, or 0, this kind of operation. So that is the operation that uses to identify the bucket it should fix into. So now my M1 movie goes to where? Based on the result that we got, yeah, that number is fixed. N minus 1 number is fixed. N is 16. For hash map, N is 16 always. So minus 1 is 15. Okay. So no, where is that? N 15. So if you run this again, so bucket M1 movie goes into which bucket? 9. So somewhere here. M1 movie goes here, and M2, the way it goes is it doesn't go and sit here. Okay, the way it goes is here like this. Your hash code of that movie, hash code of that movie, and M1 movie, and value something will be there, right? It is a key, it is a value, some value like one number of movies available, 6. Okay, this is how it goes and sit into M1 in this 9 bucket 9. Okay, next one is bucket 5, M2. So somewhere here. Okay, let's assume like blah 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 is there, 5, bucket 5, and here it will go same thing, M2, hash code of that and value will be stored. Next one is 6, here somewhere, same thing, 12 somewhere here, hash code of that movie, M4, value, bucket 3, here it will go. So this is how it stores. So that is good. How does it retrieve? Right? Let's say if more than one, now in our case we haven't encountered that same hash code value. But if you have maximum bucket size of 16, if you are trying to keep more than 30 movies, somewhere you end up with identifying same bucket name for more than one movie. So how does it happens now? Then it will go, like I mentioned in a HashSet example, it will create another bucket, another linked list, and have a connection and key value hash code. So when it retrieving, first it uses hash code and n-1 logic and identifies where it falls. Once it identifies the bucket, then it uses equals method to identify the which object among those two, which object is first object or second object, which object I need to retrieve using the equals method. Okay, clear? Somebody asked it out, right? Yeah, Shiva, did you understand? Formula is formula to store and retrieve from HashSet, HashMap, hash table. Okay, is hash code of that object and n-1. It's bitwise and okay. Clear? So that is how it stores the values. Okay, so let's go back and write some program, right? That's all our goal. HashMap, demo. here we use the same movies, but what we will say is, like, let's assume like these movies are DVDs. Okay, let's say these movies are DVDs, and you assume, like, now there is no DVD shops or the blah blah blah, but generally, right? So these movies are DVDs, and now a DVD shop owner, what he will do, definitely you will have more than one Game of Thrones CD and more than one Narcos CD, right? Number of copies will be there. Copies will be there, right? He need to keep track of Game of Thrones. He have five, and Narcos, you have 10 copies, right? As and when somebody picked up, it need to reduce that value, right? So in those lines, so we have this concept. So we want to store movie as well as number of copies. Movie as well as number of copies. How do we store that? So using key value concept. So the way we can store is now HashMap. Before we go into that, we can do simple ones. I think let's go there. There is no, I mean, we covered already. HashMap. The first object is movie, key value concept, right? Key is a movie, value is int, copies, number of copies. Okay. HashMap movie map. Okay, movie map. I'll call it as equal to. You can call it simple map also, no harm done. New HashMap key value. Okay, you don't need to mention this. Okay. Int, can you able to keep int data, primitive data type into collections? No. So what you need to do? Integer. Okay. So next one is movie map. So what I'm going to do, I'll just keep adding the movies and number of copies. Movie map m1 equal to new movie map. Sorry, movie map. Sorry. Dot. What I'm doing? Put key is movie, right? M1. Value is what? Number of copies. I have 5 copies. Oh, damn, I need to create objects. Comparator. I'll copy the here, whatever we have, right? These are your object, okay? Fine. Right. So next one I will add another movie, same thing. M2. I have 15 copies. Narcos, I have 2 copies. Fifty copies. Friends. 5 copies. Okay. So now I have a movie map which is holding values, movie object and number of copies, right? Okay. Now we want to display them. So extracting, now earlier what you used to do from the collection, all you need to do is Don't get confused. Like all you need to do is in collection, like array list or set or whatever it is, all you need to do is go to the index 1 2 3 4 and ask the value inside the index, right? And you will get that index. So using for each loop you try to extract like that. But here the challenge is your data is sitting in terms of key value, right? Key value. So how does you are able to extract? How are you able to extract these objects? So there are two ways. Okay, there are two ways to extract. You have key value like this, right? So one way is, like I said, this one is set, hash set concept, this one is list, right? So one way is concept, not really, but internal concept. You can get this piece, key piece into your hand and then get the value of particular key. Okay, get the value of particular key. Get the value of particular key, right? If you pass key 2, you will get the value 2. So that's how you can do. Otherwise, you can extract each object like this. You can extract each object like this. Either you can extract entire key set, entire key bucket outside and start extracting each and every value inside, or else either you can extract one object at a time like this. Okay, we'll see both options. So first option is, let's try to extract the object out. Okay, so what you need to do is, like I said, it's a set movie set movie map. So insertion is done as of now. Now extraction. Okay, extracting from HashMap. Equal to from where you need to extract, from movie map that you created, right? Dot key set. Okay, so when you ask like this, you will get this piece. Okay, when you got this piece, you can start asking, like the how to extract the values from the key set, right? So from here, now you got set. All you need to do is, for in set what we have, movie, right? For each movie in M set, you need to display SYSOUT movie details M plus number of copies. How do you get the value number of copies? M dot what you call it, HashMap dot, you just need to pass what you call H movie map dot get of M. You understand here? So this is the value, this is the key you try to this is the key you try to display here, and you want to get the value, right? So what you are trying to ask is movie map dot get of M1 value. When you get off M1 when you ask, you will get the value back. This M1, M2, M3, M4, M5 are keys. 15, 5, 20, 25 are values. Let me display what is the result. See, you will get the name and then number of copies, whatever the value, right? Number of copies 15, number of copies 5. If somebody taken one copy, it will become 14. You can go and update it. Okay, understood? This is one way of extracting from HashMap. Another way of extracting for HashMap is you can choose whatever you want. Okay, option 2 is another option 2. What I said, you need to get each object at a time and display these values, right? What you need to do is, there is another method that available in HashMap is for movie map dot entry set. Okay, this one is returning what? A set of one entry in that movie and integer, it will return each time. Okay, so this is a movie. So what you need to do here, map dot entry movie comma integer an entry, something like whatever the name you want. It's little confusing, but try to understand whatever we explained here, right? So second way of doing it is you have map key values. So first you need to understand how the values entered. Okay, you may be little confusing. I explained, like, it uses 16 only, and it goes index by index. That is internally what it happens. But imagine in this format. Okay, imagine in this format. Okay, so that you can easily understand. So now what we try to do is, you try to extract complete this block, key block, and extracted each and every value from here. Second option that we're trying is extract one element at a time. This piece is called as an entry. Okay, just remember, map one entry in the map. So we're trying to take out one entry at a time. So when you ask movie map dot entry set, it will give you an entry set with movie comma integer, whatever the set, first one particular object. So you need to display that set. This way, so you see movie details here. How do you get the value? Now you got this piece, complete piece. You need to display internally this piece and this piece, AB. Okay, you got this piece. You need to display key and value explicitly, right? So what you need to do, plus entry dot get key plus copies. Entry dot get value. Now let's run it again. See, there are two ways you extracted data. Okay, clear? Same thing you can do with hash table as well, tree map as well. Let's convert this one into tree map and see what happens, right? Can anyone guess what happens? No. Let's see. Because your movie doesn't have compared to object. Sorry, your movie doesn't have compared to method. Your movie doesn't implemented comparable interface. Right? So in order to do this, what you need to do first? First you need to implement. Now let's see. Implements. Oh, okay. Tell me when you guys got clarity. I'll wait for a second. How about now? Okay, good. Implements comparator. So as in when you say comparator, it asks for implementation. Add an implemented method. Go to that method and do something. I'll simply, for the sake of quickly get it done, o1 dot get name dot compare to oh, we implemented this one? No, we don't want. We want to implement what? Comparable. This dot get name dot compare to o dot get name. Okay, let's come back and start look at it. Where is that? Yeah, here. Let's run this program again. Now it worked. And here it compared and sorted your data in Breaking Bad, movie, Game of Thrones, Last Man Standing and Narcos in a name based. What it sorted, whether it sorted values or keys, you always sort keys. You always sort keys. Based on keys only the data will get sorted here and there, here and there, here. So do I need to keep always some object here? No, you can keep an integer here and movie here. Movie 1, movie 2 in the value and some unique IDs in the key. But in our case, our objects will have number of copies. That's the reason number of copies value is entered into the value. Okay. So that is another one. So last and foremost is there are again, what is the difference between HashMap and TreeMap? I'll update those things. The core functionality is same. I'll update in the website today for sure in the next couple of hours if I get time. Here, all the HashMap and hash table, linked HashMap, TreeMap. What is the difference between these four? And basically, the concept is same. TreeMap is sorted, and HashMap allows in the key only one null value. Okay, HashMap, if you try to keep null here, it allows null. But if you try to keep the null again, it doesn't allow, but value you can keep as many nulls you want as you can. Okay, this is not allowed, this is as many values can go as many nulls as it can, but key you can enter only one null, and hash table doesn't allow at all. And performance wise, and the important thing is difference between hash table and hash map is hash table is synchronized. Hash table is synchronized, which means the performance will come down, but it works fine in multi-threaded environment. Okay, whenever you heard synchronized, the things that should come into your mind is it works fine in multi-threaded environment, but the performance will be little bit low, little bit slow. Okay, so comparison in point of view, HashMap is the winner. HashMap is the best performance. Next one is what you call a TreeMap or something, and I'll differentiate and I'll update there, and then hash table. Okay, that's how it works. Then the next thing is in HashMap, what if you want to make your HashMap synchronized? Hash table is by default synchronized. When you type hash table, it will be automatically synchronized. What does it mean synchronized? You cannot update this map concurrently. If one thread is updating this map, if one thread is updating this map, if it is a synchronized or if it is a hash table, then only one thread will be allowed until that finished. Let's say one thread came and updating the number 1 value, then next thread want to update in the number 3 value. It doesn't allow until number 1 thread 1 finishes and releases. Thread 2 doesn't get to update another value, even though the value updation by T1 thread 1 and thread 2 are different, but still you don't get the access to that hash table. But in case of hash map, you will get. Okay, but you want to make hash table, there are hash map, you want to go with hash map concept, but you still want to use synchronization concept somewhere in down the program, as part of your program. How can you do that? There are two ways. Earlier way that they provided is, okay, earlier there is a concept called collections dot synchronized map, and pass your movie map. This is one way. Now your movie map is synchronized. From this line onwards, if you start using, that is thread safe, and the performance will come down a little bit compared to the movie map that worked here above this line. Okay, collections.synchronized map is used to, after implementing comparable interface, I didn't get sorted output. At the end of the class, can you show me the code once? I'll check here. Okay, yeah. Oh, I'm not sharing the programs, right? I'll do it. I'll upload into what you call GitHub. Okay, so collections dot synchronized map. By passing your simple hash map, it will get hash map got synchronized now. By default, hash map is not synchronized. Okay, maybe I'm using hash map is not synchronized by default, and in terms of map family, HashMap is the winner. In terms of map performance, map of map family, HashMap is the winner. Okay, hash table by default synchronized. Okay, in order to use TreeMap, your object must implement what is that, your object must implement java.lang.comparable interface compare to we must implement compare to method in so that TreeMap will sort based on keys, not values. Okay, and to make HashMap synchronized, you must use one of the following. Clear? Okay. So one is collections dot sorted map. Another one is there is the concept called concurrent hash map. Another map is concurrent. Say concurrent hash map. So movie integer concurrent hash map equal to same way new concurrent hash map. Okay, this is how you can start adding all the values whatever the way you did here. Now the values are getting secured explicitly. ch concurrent hash map. So there is a separate map they provided in the latest version or 7 or 6 concurrent hash map, and the difference between say by doing this way and by doing Comparator creating a new. So if you have a simple hash map, you still want to synchronize somewhere, you can go for collection.synchronized map, or else if you are sure your application is multi-threaded environment, simply go for concurrent hash map. Okay, concurrent hash map is nothing but a simple hash map, but it allows, it will be like interesting lock. It doesn't lock complete hash map object. It doesn't lock complete hash map object. So when you make this map as a synchronized hash map, what happens is, let's say thread 1 came and updating K2, V2, K3, V3, K4, V4. Okay, let's thread 1 came and try to update in thread concepts, mix the thread concept with the collections. Okay, when thread 1 came to update this one, as it is a synchronized hash map, it allows first time to update the values or key, and at the same time it will get the lock on entire object, So if thread 2 comes and try to update the third K1 K3, but it doesn't get until this guy update, even though he is updating the first index, even though T2 want to update third index, it doesn't get the access. That is what happens in collections.synchronized map if you use. But if you go with concurrent hash map, what happens? Simple. In concurrent hash map concept, K1, V1, K3, V3, K5, V5. Okay. So if thread 1 came to update this guy, and it locks only this piece. It locks only this piece, not entire object. Concurrent hash map doesn't lock entire object. So in this concept, T2 can easily update in parallel to T1. But if T2 comes to update first object, the object that is getting updated by T1, until T1 finishes, T2 doesn't get. But if T2 want to update some other element in that concurrent hash map, it can update. Make sense? Okay, that is the main difference. I will list out the clearly, like, today for sure, before next class at least, all the differences, and you can go back and check it out. Okay, that's all about collections. And two things pending: files creation, sync serialization, and enum. We'll cover in the evening class.